I'm Mike Castellano. I'm a professor of agronomy at Iowa State University. I'll be talking today about crop residue management, in particular conservation crop residue management. Crop residue production presents a growing challenge to Iowa farmers. Every year, corn residue production is increasing by about 100 pounds of dry matter per acre per year, and soybean residue production is increasing by about 40 pounds per acre per year. This residue, when left on the soil, as you can see here, it keeps the ground cold, it keeps the ground wet. This can delay planting in the spring. And a current challenge in particular is it also slows down nitrogen mineralization in the soil and can often result in greater nitrogen fertilizer needs, particularly when we're growing corn following corn. The current solution for crop residue management is often intensive tillage in the fall or even in the spring. We believe an alternative to tillage to deal with crop residue management can be the partial residue harvest. So roughly harvesting about 60% of crop residue. If we think about corn residue production growing by about 100 pounds per acre per year, corn yield is growing by about 2 bushels per acre per year. If the average yield now is about 200 bushels per acre, if we harvested 50% of our residue in a field, that would take us back to about the residue produced in around 1975, right? And so there really is growing opportunity to harvest some of this residue, particularly when we can find alternative uses for it. So for example, livestock bedding or biofuels even. When we do harvest a portion of crop residues, it allows us to do a few things. We know the soil warms up faster in the spring, it dries out faster in the spring. That allows us to plant earlier, which results in increased yields in the fall, of course. In continuous corn systems, as I mentioned earlier, it can also reduce the nitrogen fertilizer needs of the following corn crop. So in fact, when we think about things like the soybean nitrogen credit, which is a term we don't like to use anymore, really it's a continuous corn nitrogen penalty. And one of the reasons why we call it a continuous corn nitrogen penalty is indeed, if we harvest a portion of the corn residue in continuous corn systems, we oftentimes reduce the nitrogen fertilizer needs down to rates that are similar to corn following soybeans rather than corn following corn. What we're doing at this research farm is we are exploring the effects of partial residue harvest from a systems approach. We have conventional business as usual corn-soybean rotations with full tillage. We have corn-soybean rotations with no residue harvest and no tillage. And then we have a corn-soybean rotation with partial residue harvest and no tillage. We think that this is the system of the future, and we are making a variety of measurements on these systems. We're measuring things like soil temperature, soil moisture, and water flow and nitrate losses to our tile drains. Out here today, one of the particular things that we're interested in testing at this field is whether partial residue harvest improves water quality outcomes. How could partial residue harvest improve water quality outcomes? That seems like it might be a little bit of a surprise. We know that when we harvest a portion of the corn residue, it increases evapotranspiration. And the main driver of nitrate loading to our waterways is not the concentration of nitrate in the water, but it's the amount of water that's flowing to our tile drains. If we can increase the evapotranspiration by harvesting a portion of the residue, it may indeed decrease the amount of nitrate loading to our waterways. As I also mentioned, in the case of continuous corn, we may also get a concentration decrease too if harvesting a portion of that residue allows us to reduce our nitrogen needs, which long-term research from the USDA shows, in fact, that does happen. For decades, we have been encouraging residue retention as the conservation agricultural practice. But for decades, the amount of residue production has been growing. And so now there really is an opportunity to harvest some, not all, of our residue for conservation, especially if it enables us to switch to no tillage. Just recently, USDA is showing now a decrease in no tillage acres. And that is most likely due to decreased herbicide efficacy for the most part, but we believe increased residue production is also playing a role in that recent increase in tillage that we're seeing. There's a lot of barriers that excess residue production presents to the farmer. It has biophysical challenges where it keeps the soil cold, it keeps the soil wet, which is not good for early growing season production of our crops. It also creates mechanical challenges for planting into that residue. In soybeans in particular, a real big surprise is some very preliminary research from Iowa State University, funded by the Iowa Nutrient Research Center, shows that even harvesting soybean residue can improve corn yield and improve the nitrogen use efficiency of our corn. And we believe that it's due to that windrowing that we often see in our soybean fields, where we get poor residue distribution on the soil surface that creates particular challenges for early season growth in our following corn crop. We believe that there will be growing opportunities in the future to harvest residue as we find new opportunities to use that residue for things like biofuels, livestock bedding, and even some really neat alternative products like bricks and plywood substitutes can be made out of corn residue. We're very concerned by the recent increase in tillage, and we need to begin to think about new strategies for herbicide efficacy and weed management in our fields. We need to think also about the challenges that the high levels of residue create for planting and managing the following crop, which may also be contributing to the increase in tillage that we're seeing. So wind erosion, of course, is a concern because it's so visible, but really tillage erosion is the thing that we need to be concerned about. And if partial residue harvest offers an opportunity to switch to no-till and achieve the yields that we can achieve with full tillage, there's really a great opportunity to actually reduce our erosion, because all our modeling exercises show us that if we have a choice, full tillage and residue retention or partial residue harvest and no-till, the clear answer for reducing erosion is partial residue harvest and no-till. So we have a little bit of a chicken and the egg problem here, right? Where we have a new and growing resource in the state, and we need opportunities to use that resource. There are a few operations in the state that I know of that are interested in residue harvest. Two that I could identify in particular are Verbio, which is here on Highway 30. They are harvesting residue for farmers, so they have the equipment, and they take that residue and they're turning it into biogas and putting it right in the pipeline. There's another company, New Energy Blue, north of here, outside of Mason City, that is also making biofuels out of the crop residues. Reintegrating livestock and crop operations would really also provide a solution towards finding a use for that residue. In fact, what we did with the residue that we harvested here is we brought it right to the Iowa State beef production center across the field here. As farmers begin to better understand and better manage for the benefits of partial residue harvest, as this new resource grows and farmers are pulling it off the fields, we believe new opportunities for businesses will arise in Iowa to utilize that residue, whether it's for biofuels or other novel products. As we're recognizing the opportunity for partial residue harvest, conservation crop residue harvest to benefit agronomic production, increasing yields, reducing nitrogen losses to the environment, we're really trying to take a systems approach towards developing the best systems for this partial residue harvest. And that involves, again, not full residue harvest, partial harvest of the residue, a switch to no-till, which enables things like earlier planting of longer maturity crop varieties that increase yield and reduce nitrogen losses to the environment by increasing that sink for nitrogen in our harvested products. So really, Again, it comes down to a systems solution for crop residue management. It's not just pull the residue off and maintain operations as they were. We really need to think about placing the residue harvest in a system so we get the benefits while minimizing any detriments like erosion.